Hey guys, today we'll be talking about a topic on trigonometry, which is the unit circle. We'll be talking about its parts, how to use it to get the trigonometric values, and do some examples on this lesson. This short lecture is brought to you by the one and only Trigo-Nerds of 10 Pythagoras from Lagro High School. So the unit circle is a circle whose radius is equal to 1. We have this picture which shows that the vertical lines as the y-axis and the horizontal lines as the x-axis. As said before, r is the radius which is equal to 1 and theta is the reference angle. Here we have the picture of the unit circle itself. The first values are the values of the x-axis and the second values are the values of the y-axis. Now we'll be teaching you the formulas to get the different values of the trigonometric functions. For sine theta, we have to get y. For cosine theta, we just need to get x. And for tangent theta, we just need to get y over x. Now it's time for their reciprocals. For cosecant theta, we just need to divide 1 over y, or otherwise, the reciprocal of sine theta. For secant theta, we just need to get 1 over x. And of course, for cotangent, we just need to get the reciprocal of tangent theta, or x over y. So now that we know this stuff, let's try doing it, shall we? So here we have sine 405 degrees. So since that's more than 360, we just need to get the coterminal. So it's 405 degrees minus 360 degrees, which is ta-da! 45 degrees. So we have 45 degrees, and the answer to that is square root of 2 over 2. That's the trigonometric value of sine 45. If we check the unit circle, we can see that the y value of 45 degrees is square root of 2 over 2. Therefore, we got the correct answer. Another example where we are given cosine negative 120 degrees. We need to get the coterminal first of negative 120 degrees, so we add 360 degrees to it and get 240 degrees. Now we need cosine 240 degrees, and the answer is negative 1/2. On our unit circle, we could see that the x of 240 degrees is negative 1/2. Therefore, we got the correct answer. So now we'll be talking about the 4 quadrants of the unit circle. In each quadrant, there are 3 angles. So for quadrant 1, we have 30 degrees, 45 degrees, and 60 degrees. For quadrant 2, we have 150 degrees, 135 degrees, and 120 degrees. For quadrant 3, we have 210 degrees, 225 degrees, and 240 degrees. For quadrant 4, we have 330 degrees, 315 degrees, and 300 degrees. Now if you look at the angles in a horizontal way, we will find out which angles have the same values though they differ in signs, whether they are positive or not. 30 degrees, 150 degrees, 210 degrees, and 330 degrees have the same signs. 45 degrees, 135 degrees, 224 degrees, and 315 degrees have the same signs. And the 60 degrees, 120 degrees, 240 degrees, and 300 degrees also have the same signs. For the angles that are in the same group as 30 degrees, the values are positive and negative square root of 3 over 2, and positive and negative 1/2. For the angles that are in the same group as 45 degrees, the values are positive and negative square root of 2 over 2, and positive and negative square root of 2 over 2. And for the angles that are in the same group as 60 degrees, the values are positive and negative 1/2 and positive and negative square root of 3 over 2. In the unit circle, there are only certain quadrants where the trigonometric functions could be positive. For quadrant 1, all of the trigo functions can be positive. For quadrant 2, sine and cosecant are the only ones that can be positive. In quadrant 3, tangent and cotangent could be only positive. And for quadrant 4, secant and cosine can be the only ones that can be positive. Now let's apply the whole thing into the lesson. So here we have cosecant 4 pi over 3. Since it is in radians, let us convert it to 240 degrees. Now 240 degrees is in quadrant 3, but cosine cannot be positive in quadrant 3. Therefore, the sign is negative. If we're going to check the unit circle again, we can see that only tangent and cotangent can be positive in quadrant 3. Therefore, we were correct. Another example is tangent negative 8 pi over 3. If we convert it into degrees, we get 480 degrees, which is 240 degrees as one of its coterminals. 240 degrees is in quadrant 3, where tangent could be positive. Therefore, the sign is positive. On our unit circle, we could see that tangent would be positive in quadrant 3. Therefore, we got the correct answer. But now let's say we need to find sine theta, that is equal to 1/2, with the restrictions 0 degrees and 90 degrees. We need to find the angle needed instead of the value, and it should be between 0 and 90 degrees. In the unit circle, we need to find 1/2 as their y, which could be found with 30 degrees and 150 degrees. Therefore, theta could be 30 degrees and 150 degrees. But it should be between 0 and 90 degrees, so we cross out 150 and our theta is really 30 degrees. And that is the end of the lesson. We would like to thank our Trigo teacher, Mr. Julius Abel Galpao, for this wonderful project and for teaching us what we know on the lesson. The members of this group are Patricia Mae C, Dacanay, Blesie Joy B, Jaie, Margaret C, Malonzo, and Ryan Jalmasco of 10 Pythagoras. Thank you so much once again, and this is the unit circle taught by the Trigo-Nerds.